Hello, good morning. Good morning, everyone. I think we are live. Hope you're feeling wonderful today. I'm feeling a little wonderful today. Let me see. I want to check if we're live. We are. Nice. Okay. Um, I wanted to stream last night and I couldn't because there was some exciting news at the company. A couple of public articles. Maybe we'll go through them today. Yeah. Before we get started with the stream, I wanted to say something. Yeah, last night. Okay, let's. We'll get it in the stream agenda, so that I don't forget about stuff. So, before we copy this, paste it in here. See, it's 7:43. We're up and running. Because I wasn't able to stream last night, and I thought if I wouldn't stream in the morning, I might not make stream the entire day. I want to like get this out of the way. I'm also going to work today, so things might be a little tricky, but I'm glad I woke up early and I could stream. I should be running or lifting weights, but it's fine. I'm enjoying this process too. Agenda. I want to go over notes. Actually, let's start with the important P1 first. The P1 is understanding how search works, which and I also let me quickly pull up my blog. So I think I'm not sure if I did it on the blog or offline, but I did push out another article, and yeah, so I starting to feel like I might be writing too much stuff. I mean, it's not. It's just 4 articles, but I was just wondering, like, if this is something that will actually scale. So I want to start adding. I mean, like, because the ultimate goal is to have a lot of articles in place, and I don't like the current experience right now. Like, I'm not able to like search for something that I want, or like I don't see anybody be able to use this page to the full extent with the current experience. So there are like different ways to solve this problem, right? Like, for example, like I can add like search, which is what I wanted to like study today. I can do tags. Maybe I can uh, change the layout. There are like different ways. So we'll also talk about that. So I think that should be step one, because uh, think of ideas on how to improve the writing page. Just copy this and keep it nice and clean. Then we'll understand how search works, and then go over some notes, and then I want to create a couple of tasks. YouTube summarizer. Written docs for WhatsApp. So I signed up for, if you remember the other day we were building an N8N workflow to sync Strava data to WhatsApp, some sort of that. I thought there's another key that we can. So we stopped that midway. Uh, this is not it. This we should delete. Where is my Strava workflow? It's so sad. Yeah, I need to save this. How do I navigate this? Yes, bro. Uh-huh. Okay. Yes, yes. Streaming. Look at this. Look at this. Look at this. Okay, we just need one, and I think that's good. Okay, so that's the agenda. I think this is like a lot of stuff to go over. So let's start with this. Incorrect link. Yes. Let's start with some GPT. So those are the ideas that I was thinking of, tags and search, but it's a nice way to think about it. Character Notion. Oh. So I don't want to stress it. I think this is good enough like knowledge for right now. Like I want to start with that, then move on to search. What do I want to do? To name it projects, then filter for yes. I want to duplicate it. Got it. It was just very dirty to see all of those previous projects and so on. And that's why I'm like unarchive. Don't know if I need this here. personal website, it's happening in multiple steps. I don't see the notes of the fan. Too long. Favorites. Okay, let's find some video on how search works.
Today, we're going to explore the complex systems that make web search possible. We'll follow the journey from web pages to search results, looking at the technical challenges at each stage. Web crawling forms the bedrock of search engine functionality. It's a complex process that scours and indexes the internet. Search engine deploys advanced crawlers that combine breadth-first and depth-first strategies to efficiently explore web pages. These crawlers begin with breadth-first and depth scours and indexes the internet. Search engine deploys advanced crawlers that combine breadth-first and depth-first strategies to efficiently explore web pages. These crawlers begin with seed URLs and follow hyperlinks to discover new content. As they scan the web, crawlers gather vital data about each page, titles, keywords, and links. This information is then stored for processing. Crawlers must intelligently prioritize which pages to scan based on factors like external link count, update frequency, and perceived authority. Managing the URL queue is important. Search engines use sophisticated algorithms to decide the crawling order, balancing new content discovery with a thorough exploration of existing sites. New sites might be crawled every few minutes, while less frequently updated pages might only see a crawler once a month. Even with their immense processing power, search engines can only crawl a fraction of the internet daily. They carefully allocate a crawl budget based on site architecture, site maps, and internal link quality. This ensures priority for the most important and frequently updated content. Crawler also tackle the challenge of identifying and handling duplicate content. They use URL normalization and content fingerprinting to avoid redundant crawling, optimizing resources and efficiency.
miss having my notebook in.
Modern websites often rely heavily on JavaScript for dynamic content generation. To address this, crawlers use a two-phase approach, first crawling static HTML, then rendering JavaScript to capture the full page content. This process is computationally intensive, highlighting the importance of efficient web development for better search engine visibility. As crawlers navigate the web, they extract and categorize outgoing links, distinguishing between internal and external links. This information is used for subsequent indexing stages, particularly in analyzing page relationships and determining relative importance. The crawling system doesn't just collect data, it makes important decisions about content handling. Some pages may be immediately forwarded for indexing, while others might be placed in a separate area for further evaluation. This helps filter out potential spam or low-quality content before it enters the main index. Once a page is crawled, the indexing process begins. This involves analyzing and categorizing the content and creating a structured database for quick and efficient retrieval when a search query is made. The indexing system assigns unique identifiers to each piece of content, ensuring effective tracking and management even for similar information across multiple URLs. The process starts by breaking down page content into individual words and phrases. This is straightforward for languages like English, but becomes more complex for languages without clear word boundaries, such as Chinese or Japanese. The search engines then processes these words to understand their basic forms and meanings, recognizing that running, runs, and ran all related to the concept of run. Context analysis is next. Search engines examine the surrounding text to determine whether Jaguar refers to the animal or the car brand. This deeper understanding of language and context is vital for providing relevant search results and accurate answer to user queries. The processed text feeds into the indexing pipeline, with the inverted index at its core. This powerful data structure enables rapid retrieval of documents containing specific terms, essentially mapping which words appear in which documents. This allows
Hi, my name is Matt Cutts. I'm an engineer in the quality group at Google, and I'd like to talk today about what happens when you do a web search. The first thing to understand is that when you do a Google search, you aren't actually searching the web. You're searching Google's index of the web, or at least as much of it as we can find. We do this with software programs called spiders. Spiders start by fetching a few web pages. Then they follow the links on those pages and fetch the pages they point to, and follow all the links on those pages and fetch the pages they link to, and so on, until we've indexed a pretty big chunk of the web, many billions of pages stored across thousands of machines. Now, suppose I want to know how fast a cheetah can run. I type in my search, say cheetah, running, speed, and hit return. Our software searches our index to find every page that includes those search terms. In this case, there are hundreds of thousands of possible results. How does Google decide which few documents I really want? By asking questions, more than 200 of them, like, how many times does this page contain your keywords? Do the words appear in the title? In the URL? Directly adjacent? Does the page include synonyms for those words? Is this page from a quality website, or is it low quality, even spammy? What is this page's page rank? That's a formula invented by our founders, Larry Page and Sergey Brin, that rates a web page's importance by looking at how many outside links point to it and how important those links are. Finally, we combine all those factors together to produce each page's overall score and send you back your search results about half a second after you submit your search. At Google, we take our commitment to delivering useful and impartial search results very seriously. We don't ever accept payment to add a site to our index, update it more often, or improve its ranking. Let's take a look at my search results. Each entry includes a title, a URL, and a snippet of text to help me decide whether this page is what I'm looking for. I also see links to similar pages, Google's most recent stored version of that page, and related searches that I might want to try next. And sometimes, along the right and at the top, I'll see ads. We take our advertising business very seriously as well, both our commitment to deliver the best possible audience for advertisers and to strive to only show ads that you really want to see. We're very careful to distinguish your ads from regular search results. And we won't show you any ads at all if we can't find any that we think will help you find the information you're looking for, which in this case, the Cheetah's top running speed is more than 60 miles an hour. Thanks for watching. I hope this made Google a little bit more understandable.
Larry Page and Sergey Brin founded Google back in 1998, and today folks around the world use Google every day, typing a billion search queries for news, recipes, reviews, directions, and anything you can think of. Users also rely on Google search as an entryway to their favorite websites. Some of the most searched for terms are actually just YouTube and Google. This means that making sure your website is indexed and ranked well in Google search results is essential for connecting with your target audience through search. But do you know how a Google search result page comes together? And how to identify opportunities to make sure your website is fully Googleable? Oh, by the way, I'm Gary. I'm an engineer on the search team at Google. Welcome to How Search Works, a 5-part series exploring how Google search, well, works, technically. See how I emphasize technically? We created this series to help you, your friends, family, business partners, and anyone really increase the visibility of your sites. The way we do this is by offering a deeper dive into the mechanics of search. If you are just looking to demystify how search works generally, check out our 5-minute video explainer. In this series, we are going to explore the 3 main stages of search. Crawling, how Google discovers URLs and explores the internet. Indexing, or the way Google understands what the page is about and its relation to other pages on the internet. And also stores that information in a searchable way. And then finally, serving, or how Google actually serves and ranks results. Then we'll take a look at a results page, break down the components of text results, and take a look at the different attributes you can add to your pages to increase the visibility of your sites. By the end of this How Search Works series, you'll be able to explain for yourself what crawling, indexing, and serving all mean in relation to Google search, the way web pages are ranked, and how to influence the way your site's results look like in search. It should be pretty interesting. Before we dive in though, there are 2 things you need to know. First, Google doesn't accept payments to crawl a site more frequently or rank it higher. If anyone tells you otherwise, they are wrong. Second, having a Googleable website, especially one that shows up near the top of results, is highly dependent on the quality of your page's contents. For example, large amounts of gibberish text will do poorly in search results. That will make more sense once we go over how Google sees the information on your website's pages. Okay, that's enough introduction. Let's explore crawling in the next episode. And don't forget to like and subscribe for more search content. Today, we demystify the crawling process. In this video, I'll talk about how Google search finds and fetches web pages, a process commonly called crawling. I'll explain what Googlebot is and does, then I'll talk a little bit about why sitemaps are such a helpful thing to add to your website. If you followed me here from the introduction video, welcome back. To newcomers, welcome to How Search Works, a series where we explore the basic technical functions powering Google search. Check out episode 1 somewhere here. Oh, and I'm Gary, an engineer on the search team at Google. Crawling is the process of finding new or updated web pages using automated programs called crawlers and downloading them to make them searchable. The first step in the crawling process is called URL discovery. Before Google can surface a web page in its search results, it has to know the page actually exists. Google is constantly looking for new and updated pages. However, with trillions of URLs on the internet, some will never be discovered. New pages are usually discovered when Google follows a link, a URL more precisely, from a known page to a new page. For example, from a hub page like categories to a new page. Most new URLs Google discovers are from other known pages that Google previously crawled. You can think about a news site with different category pages that then link out to individual news articles. Google can discover most published articles by revisiting the category page every now and then and extracting the URLs that lead to the articles. Crawling is done by a crawler, a piece of software that browses the internet, downloads web pages, and extracts links that it can then download again. It's a lot like a browser being controlled by a bot instead of a human. Google's main crawler is called Googlebot. Googlebot uses algorithms to determine which sites to crawl, how often, and how many pages to fetch from each site. Algorithms are processes, or if you like, sets of rules combined to achieve a specific functionality within computer programs. Googlebot is also programmed to avoid crawling the site too fast to avoid overloading. The crawling speed is unique to every single site and is largely based on how fast the site reacts to the individual requests by Googlebot, the quality of the content in general, and any potential server errors, and also other signals. Googlebot does not crawl every URL it discovers. Some pages might be on sites that don't meet the quality threshold required to get indexed, which we'll talk about more a bit later. Other URLs may be disallowed for crawling, while others might not be accessible without logging into the site. Googlebot will only crawl publicly accessible URLs. If you place something behind a login page, Googlebot can't crawl it. Once Googlebot has found your URLs, the next step is downloading, or fetching if you like, and then rendering the page hosted under that particular URL. The fetching process is just downloading the data that's served from a certain URL. Rendering is more interesting though. It is basically the same thing your browser does. The rendering service takes the page downloaded from a URL, which is usually a mix of files containing HTML, CSS, and JavaScript, and turns it into a visual representation of that page. In doing so, it will run any JavaScript it finds using a recent version of Chrome. Rendering is important because websites often rely on JavaScript to bring content into the page and to make it more lively. And without rendering, Google would not see the content. And of course, would miss out on all that liveliness, blinking elements, and scrolling text you can't possibly read. I do love JavaScript. Anyway, this ends the crawl process. Before we move on, let's talk about sitemaps. Sitemaps are a collection of URLs to pages on your site, and they are a great help if you want your site discovered by Google. The most popular format is an XML file, which allows you to provide not only the URLs of your pages, but also some additional metadata about them. Sitemaps are absolutely not mandatory, but they can definitely help Google and also other search engines find your content. If that caught your attention, work with your website provider or developer to make sure that your website generates sitemap files automatically. While you could sit in a corner and manually add all those 7 million URLs to your sitemap, that is a lot of work and is an unnecessary source of errors. Have your site's content management system make sitemap files for you. Now that you know how Google finds and fetches web pages, how does Google manage to make your pages available through search? I'm going to cover that in our next episode, indexing.
Actually, this is not what I wanted to study. I wanted to study something else. But I think
Hey,
it's just like little
welcome back to
interesting,
How
so
Search
we'll
Works.
just
I'm usually
close
Gary, an
this.
engineer on the Google Search team. In our last episode, we explored how Google finds and downloads new and updated web pages, a method called crawling. In this video, I'll talk about the next stage in the process, indexing. Once the page has been crawled and rendered, the next step is figuring out exactly what's on the page and determining some signals that will help us decide whether we should index the page. Google wouldn't be very useful if it didn't understand that some pages are recipes, some pages are articles, and so on. Likewise, if the individual words and phrases are not extracted from the downloaded pages, users would have a very hard time finding them. Simply put, this is the process of indexing. Indexing includes processing and analyzing the textual content, key content tags, attributes, images, videos, and calculating signals that Google can use to rank the pages in its search results. First, Google parses the HTML and fixes any semantic issues it may have encountered. This will make sure that all the HTML tags are in the right place and where they need to be. For example, one of the most important elements in HTML is the element which typically contains metadata about the page itself in the form of meta tags and link tags. There are very few valid HTML tags that may appear in this section of the HTML, and if an unsupported tag is used, Google, and also other browsers, will forcibly close the element right before the unsupported tag. This will leave any other metadata out of the element, rendering them useless for indexing purposes. Once the HTML is in a suitable format, Google determines if the page is a duplicate of another already known page, and which version should be kept in the index, the canonical version. Right, but in this context, the canonical version is the page from a group of duplicate pages that best represents the group according to the signals we've collected about each version. For the most part, only canonical pages appear in search results. Sure, but how do we know which page is canonical? I know. Stop it. Go away. Okay. So, once Google has the content of your page, or more specifically, the main content or centerpiece of a page, it will group it with one or more pages featuring similar content, if any. This is duplicate clustering. Then it compares page in the index, determines the indexing and analyzing the textual content, key content users with determining some signals that hold and render. Once the page has been crawled and rendered, the next step is figuring out exactly what's on the page and determining some signals that will help us decide whether we should index the page. Google wouldn't be very useful if it didn't understand that some pages are recipes, some pages are articles, and so on. Likewise, if the individual words and phrases are not extracted from the downloaded pages, users would have a very hard time finding them. Simply put, this is the process of indexing. Indexing includes processing and analyzing the textual content, key content tags, attributes, images, videos, and calculating signals that Google can use to rank the pages in its search results. First, Google parses the HTML and fixes any semantic issues it may have encountered. This will make sure that all the HTML tags are in the right place and where they need to be. For example, one of the most important elements in HTML is the element which typically contains metadata about the page itself in the form of meta tags and link tags. There are very few valid HTML tags that may appear in this section of the HTML, and if an unsupported tag is used, Google, and also other browsers, will forcibly close the element right before the unsupported tag. This will leave any other metadata out of the element, rendering them useless for indexing purposes. Once the HTML is in a suitable format, Google determines if the page is a duplicate of another already known page, and which version should be kept in the index, the canonical version. Right, but in this context, the canonical version is the page from a group of duplicate pages that best represents the group according to the signals we've collected about each version. For the most part, only canonical pages appear in search results. Sure, but how do we know which page is canonical? I know. Stop it. Go away. Okay. So, once Google has the content of your page, or more specifically, the main content or centerpiece of a page, it will group it with one or more pages featuring similar content, if any. This is duplicate clustering. Then it compares a handful of signals it has already calculated for each page to select a canonical version. Signals are pieces of information that the search engine collects about pages and websites which are used for further processing. Some signals are very straightforward, such as site owner annotations in HTML like rel canonical, while others, like the importance of an individual page on the internet, are less straightforward. Each of the duplicate clusters will have a single version of the content selected as canonical. This version will represent the content in search results for all the other versions. The other versions in the cluster become alternate versions that may be served in different contexts, like if the user is searching for a very specific page from the cluster. But let's move on to index selection. Once the signals are collected and duplicates dropped, Google decides whether or not to index the page. This process is called index selection. It largely depends on the quality of the page and the signals that we've previously collected. If a canonical page does get indexed, then we store the information that we collected about it and its cluster in the Google index. Google's index technically is just a large database sitting on thousands of computers. However, talking to it the right way, it returns results highly relevant to whatever we are asking. Okay, but how? I'll answer that in the next episode, which will be about serving and ranking search results. Until next time, don't forget to like and subscribe for more search. Hi, I'm Gary. I'm an engineer on the search team at Google. Did you know that Larry and Sergey originally called their search engine Backrub? If we hadn't changed the name to Google, you'd now be watching the How Backrub Works video? Anyway, welcome back to How Search Works, where we explored basic technical functions powering Google search. In our previous video, we learned how Google crawls web pages and indexes their contents. Now, it's time to actually serve and rank the results based on that content and what users are looking for. When you enter a query into Google, our machines search our index for the matching pages and return results we believe are the highest quality, trustworthy, and most relevant to your query. Retrieval of the results begins with interpreting the query. First, the query is cleaned up, then checked for certain entities. For example, the query "a nice photograph of the moon" doesn't actually require the stop words "a," "of," and "the," and so we'll scrub those out. However, the Statue of Liberty does require "of," so we'll leave it in. Additionally, the Statue of Liberty is recognized as its own entity. The query will also be expanded to include similar words. For example, searching car dealership will expand to include auto dealership because car and auto are close synonyms. Once we understand the query, we can send it to the index. Based on the parsed query, the index will return a large number of results that will need to be ranked. Ranking largely depends on the relevancy of the results to the user. Hundreds of factors determine relevance, with the actual contents of the page being the most important one, but also things like the user's location, language, and device type. For example, searching for bicycle repair shops shows different results to a user in Paris than it would to a user in Hong Kong. We also need to take the quality of the page and the site into consideration during ranking. Quality is determined by a number of factors like the uniqueness of the content, the relative importance of the page on the internet, and a lot more. For more detail on how we determine and think about quality in general, we've published several help pages you should check out, linked in the description. Based on the user's query, the search features that appear on the search result pages may also change. Going back to our query, bicycle repair shops, you'll likely see local results and no image results. However, searching for modern bicycle is more likely to show image results instead of local results. I do wonder what would happen if we search for JavaScript bicycles. Well, try it out. In the final episode of How JavaScript bicycles. Well, try it out. But if we search for JavaScript bicycles. Well, try it out. In the final episode of How Search Works, I'll explain the different parts of text results, and we'll also look at how to control them. Should be pretty interesting. Join me next time, and don't forget to like and subscribe for more search content. Welcome to the final episode of How Search Works. I'm Gary, an engineer on the search team at Google. A big thank you to everyone who's been tuning in since the beginning, when we first set out to demystify the process that creates Google search results.
I think videos weren't really great. Like at least like I can like really take away a lot of information. So just try to like ask it a couple of questions and do like a nice blog post and then add it to my notes. But I get the overall idea. I don't have like in-depth idea, which is like sad because that's what I was aiming for. But then I still feel like I've learned more than like I learned a lot of stuff that I didn't know before, which is nice.
Results. For those just now tuning in, there are 4 episodes before this one. Check out links to those episodes in the description. In the previous video, we explored how Google presents information collected from the internet in response to users' queries. Today, let's explore what happens when a query returns results. Google can return many different kinds of search results, but we are going to focus on the primary type of results, text results. Historically also called 10 blue links or just blue links, these results have evolved considerably over the years, but they still have the same basic elements. Each text result consists of at least one title link and a snippet. The title link is probably the most prominent part of the search result. It's the part that jumps out at you as soon as the results appear. Title links are generated based on the content of the page. In many cases, the title link is identical to the title element of the HTML on the page, which site owners have direct control over. It may also be the headings on the page, which, again, means that site owners can control them. In some cases, especially where the content of the page is unavailable for some reason, it may be generated using external sources like anchor texts, which are the visible part of links. The snippet of a text result, just like the title link, comes from the content of the page. If the content is unavailable, then the result might not have a snippet at all. In general, the snippet is chosen from what the users would see when they land on the page. But if there's not enough text on the page, it might be picked from otherwise invisible text to users, such as the alt attributes of images and the description element. Since the text of a snippet only comes from the content of the page, you have direct control over it, and you can experiment with what we show in the search results pretty easily. You can also control whether we show a snippet at all in search results for any particular page that you own using the noSnippet robots meta tag. And you can control how long the snippet may be with the maxSnippet robots meta tag. If you don't want a particular passage to appear in the snippet, you can control the top of the page. Or just from the internet in response to this one. Welcome to the final episode of How Search Works. I'm Gary, an engineer on the search team at Google. A big missed if there are 4 episodes before this one. We explored how Google presents information collected from the internet in response to users' queries. Today, let's explore what happens when a query returns results. Google can return many different kinds of search results, but we are going to focus on the primary type of results, text results. Historically also called 10 blue links or just blue links, these results have evolved considerably over the years, but they still have the same basic elements. Each text result consists of at least one title link and a snippet. The title link is probably the most prominent part of the search result. It's the part that jumps out at you as soon as the results appear. Title links are generated based on the content of the page. In many cases, the title link is identical to the title element of the HTML on the page, which site owners have direct control over. It may also be the headings on the page, which, again, means that site owners can control them. In some cases, especially where the content of the page is unavailable for some reason, it may be generated using external sources like anchor texts, which are the visible part of links. The snippet of a text result, just like the title link, comes from the content of the page. If the content is unavailable, then the result might not have a snippet at all. In general, the snippet is chosen from what the users would see when they land on the page. But if there's not enough text on the page, it might be picked from otherwise invisible text to users, such as the alt attributes of images and the description element. Since the text of a snippet only comes from the content of the page, you have direct control over it, and you can experiment with what we show in the search results pretty easily. You can also control whether we show a snippet at all in search results for any particular page that you own using the noSnippet robots meta tag. And you can control how long the snippet may be with the maxSnippet robots meta tag. If you don't want a particular passage to appear in the snippet, you can use the data noSnippet HTML attribute on certain HTML elements. The other prominent features of a text result are the attribution features, which are the favicon of your site, the site name, and the visible URL, including breadcrumbs. Naturally, you can influence each of these in various ways. For example, changing your URLs might change the breadcrumb. Changing structure data might update your site's name, and uploading a new favicon to your site will update the favicon in the search results. In the snippet itself, sometimes you can see a byline date, which is an estimation by Google for when the particular page was updated or even published. Below the snippet, you can sometimes see site links, 2 or more links from the same domain or its alternate version, clustered together to help users reach pages that are relevant to that particular result. And that completes the basic anatomy of a search result. And that's it. I sure hope it was interesting. Thank you for letting me be your guide to how
I want to eat something. I'll just be back.
Monkey can play video games for 2 hours straight. Monkey can scroll through TalkTick until his thumbs go numb. Monkey can binge an entire Netflix season and call it just one more episode. But ask Monkey to sit down and study for 30 minutes? Suddenly, Monkey acts like he's being tortured in the banana mines. And starting a side project? Monkey promises to work for an hour, but 5 minutes later he's already sneaking toward the fridge, pretending cleaning counts as productivity. Here's the paradox. Monkey actually knows deep down that studying, exercising, or even cleaning his room would bring long-term rewards, but Monkey still prefers the quick hits: video games, social media, TV. Why is that? Why do some monkeys out there seem motivated to tackle hard stuff every single day, while this monkey would rather nap? And the big question, is there a way to trick monkey brain into liking hard things? Part 1. Dopamine. The answer starts with a tiny chemical inside monkey's brain: dopamine. People often call dopamine the pleasure molecule, but that's not quite right. Dopamine doesn't make monkey feel pleasure. It makes monkey want. It's the craving chemical. Dopamine is the invisible banana dangling in front of monkey's face. Monkey hasn't even eaten the banana yet, but the mere thought of it gets him running. Part 2. Rat experiments. To understand
Larry Page and Sergey. Today we did. Hey, welcome back. Hi, I'm Gary. I'm an engineer on the search team at Google. Did you know that Larry and Sergey originally called their search engine? Welcome to the final episode of How Search Works. I'm Gary, an engineer.
To understand how powerful dopamine is, let's look at monkeys' distant cousins, the lab rats. Scientists once gave rats
Oh shit. I was on mute all this while. Shit. It's okay. Stuff happens. I think I should just do like another set of recap just because I was on mute all this time. So closed all of these tasks. Tomorrow I will try to add in the tags to the web page because it'll build experience. Yeah, apart from that there's nothing much. I did some commentary on all of these, but I think it's fine. Like we'll figure this out later. Okay, I will leave for now. I hope you all have a good day. Bye. Let me actually take a picture. A little bummed about me being on mute though. Very beginner mistake, but no, I'll just forget about it. Okay, good day. Bye everyone.